The Doppler effect is perhaps best explained visually. So here's a thing that is emitting waves. It could be a fire truck emitting sound, it could be a star emitting light, it could be a duck creating ripples on a pond. Those are all waves, and they all look something like this. We see the Doppler effect happening when the thing that is emitting waves moves. In the direction it's moving, the wavefronts bunch up, and behind it they spread out. If our object is moving towards a stationary observer, these bunched up waves are observed at a high frequency, and if the object is moving away from a stationary observer, the waves are observed at a lower frequency. So that is the Doppler effect, the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer. It makes sense, but it gets interesting when you consider some of its applications. So let's say you are standing in the middle of a road. That's you, and a car drives past you very fast. As it does so, it honks its horn, because you're standing in the middle of the road. The horn to you might sound something like this. So it starts at a high pitch and moves to a lower pitch, even though from the driver's perspective the horn is playing the same pitch the entire time. So what's going on? As the vehicle's coming towards you, the sound waves that it's emitting bunch up, and so are delivered to you at a higher frequency, which you interpret as a higher pitch, because the frequency of sound waves is pitch, and then when the vehicle passes you and is moving away from you, the sound waves spread out, and so you hear them at a lower frequency, a lower pitch. So that's how the Doppler effect works with sound. It also affects another kind of wave, light.
Hey everyone, we're supposed to thrive and survive. You just got a little insight into what we're going to be talking about today, the Doppler effect and flat Earth. Meet Henry. There's Henry there. He's perplexed. Why is Henry perplexed? Well, Henry's perplexed for a couple reasons, but mainly because he doesn't understand what he just heard about the Doppler effect. You see, Henry is a recent graduate of a high-grade university, and however, even after learning all of the trash that they threw at him, he realized that the Earth was not exactly spinning. He realized that it's a flat Earth and not moving. So when he started contemplating the Doppler effect and its its applications to our life, he became perplexed. He was wondering, why does a train, when it's moving from west to east, sound exactly the same as a train moving from east to west? You see, because a train moving from west to east, its Doppler effect should be so diminished, in fact, that it would never happen on a train heading from west to east, because he and the atmosphere are turning away from the sound waves faster than they are traveling towards him. In fact, if a lightning bolt were to strike to the west of Henry, he should never hear the thunder, because the speed of sound is less than 800 miles per hour. And old Henry, he realized what they were teaching was the Earth was spinning away at least 800 miles per hour to his latitude. Now, if he was down closer to the equator, it'd be 1,000 miles per hour. Every second that went by, he would be farther and farther away from the sound waves. And yet something from the east, he would hear much sooner than something from the north or south, correct? We don't witness this, do we? This is absolute proof that the Earth is not moving. Absolute proof. Find someone who can get around the Doppler effect. Not only does it work with trains, but it works with lightning, it works with anything else, because when sound is involved, there are certain principles and properties that just can't be changed. So if you're moving away from something at 800 miles per hour and it's traveling towards you at 790 some miles per hour, it will never catch you, will you? Well, you might get it on the other side of the Earth, but I think the sound would be too diminished by that time. So anyway, just wanted to show you how the Doppler effect proves that the Earth is not spinning. So Henry doesn't have to be perplexed. He knows he's right. He can totally trash the rest of the education he was holding on to. He now realizes that things, even that science came up with that were correct, prove that the Earth does not move. The Doppler effect. See if anyone can disprove that one. Take care, guys. Bye.